So far, this chapter, we have talked about all kinds of different graphs and how to use them. And so this last lesson kind of wraps up these concepts. When you're reading and identifying information from a graph, the first thing that you should do is look at the title. Why?
Because titles tell you what you're looking at.
Yeah, exactly. Yep, you need to know what you're looking at. If you're looking at a bar graph and it is comparing the number of inches of rainfall over the course of different months, you get a general idea, oh yeah, okay, this is comparing those months and what's happening, okay? The next thing you should do is look at the type of graph, because the type of graph they chose to use might tell you what it is that they're trying to convey in the graph. For example, if it's a line graph, then what might it be trying to show you? Katie?
Things over time.
Things over time. What's happening over time, right? Because the line graphs are best for doing that. All right? If it's a circle graph, then
Comparing multiple things.
Multiple things to the
whole.
to the whole. And the numbers, you should also keep in mind that if you're looking at the number, it might be referring to the percent. So in other words, out of 100, even if the number of people that are represented in the circle are not 100, if the numbers are written as a percent, it means that if there were 100, this is how many there would be. Okay? If it's a histogram, then what's that good for? Melina?
It's good for seeing, I don't know.
Both comparing, oh, go ahead.
They show the frequency of something with an interval.
Yeah, so it compares different intervals and the frequency of those intervals, and it also shows a trend over time. Okay? So you can get both of those things. You can analyze the data. The last thing, once you've figured out what the graph is by its title and by looking at the type of graph, then you can look at the numbers and analyze them. Now we've learned how to find the mean, the median, the mode, the range, and you can use that then to answer some questions. Let's look at the first one. On the RW56, you're given a graph. What type of graph is it?
Line graph.
It's a line graph. What's the title?
Average reaction time.
Average reaction time of
Peter's
classmates. Peter predicted that as the day gets later, people's reaction time slows down. Maybe they run out of steam. So he tested his classmates' reaction time throughout the day. Look at the data in the graph. Was Peter's prediction accurate? So reaction time, testing reaction time. That would be like, if you ever seen this experiment where you put a stick or a string, it works really well with a yardstick, and somebody holds it right in between your fingers, and then as soon as they drop it, you try to catch it. And as soon as you see it starting to drop, you catch it, and you can measure the distance on the ruler to measure the reaction time. Isn't that cool? It's fun. So, this is something like what he may have done. What are you asked to find in the graph? Number one, it's a line graph, so what are we asked to find based on the fact that it's a line graph and the title? Maya?
Like how much people's reaction times changed over each time.
Over time, right, over time. How does it change over time? How does the reactions of people change over time? So that's be the answer to number one. How the reactions of students or Peter's classmates changed over time. Number 2, what was Peter's prediction, Aiden? How did he think the reaction time would change over as you went later in the day? It would get slower, yes. What would happen to the numbers if they got slower? Since the numbers on the side say reaction time in seconds, how would the actual numbers change to show that if they got slower or faster?
So if it took you a longer amount of time to catch it, then the numbers would be larger if you're counting up from 0. So longer, the bigger the number.
Correct. Yeah, the higher the numbers, the slower you are to catch it. That equals slower times, right? So, another thing you have to do when you're paying attention to a graph is to figure out what do these numbers actually mean. The fact that the line is going up means what? Is that faster or slower? Does the line going up mean faster or slower times? Devlin?
Slower.
Slower times, right. Yep. So, when were the fastest times? At what time of the day were the fastest times? Kaden?
7 p.m.
And?
10 a.m.
And 10 a.m. Yep. And what happens at 10 p.m. or from 7 p.m. to 4 a.m.? Grace?
They go up.
They go up. Yeah. Now think about that time of the day. Why do you think the reaction times would go up? From 7 p.m. to 4 a.m. Sophie?
Because everybody's tired.
Because they're tired, yeah. Think about it. Your brain is probably used to sleeping at that time, right? So, it would make sense that the reaction times went up the further past bedtime you get, right? So this graph makes a lot of sense when you start to look at all of the pieces. Look at number 3. Is a slower reaction time a higher or lower point on the graph? We already said that would be a higher point. So number 3 is a higher point, because the higher point means it took more time. More time in seconds is a slower time, a slower reaction time. Number 4, between what hours does the graph increase? We already talked about this. Sinji? Number 4. Between what hours does the graph increase? 7. What?
7 a.m.
7 a.m. Does the line go up from 7 a.m.? Find the point on the graph where it says, shows 7 a.m. Point to it. Yeah, so what happens with the line from 7 a.m. to 10 a.m.?
It increases.
Does it go up or down?
Yeah.
It goes down. So what is increasing? What's increasing during that time?
Time.
Okay, the reaction time is increasing, meaning that it's you're really good, your reactions are better during that time, right? Now, let's look at the question again. Between what hours does the graph increase? Not the times, not the reaction times are better, but the reaction times start to get worse. From 7, not 7 a.m., but 7, from here to here, right? So from
7 p.m.
to,
4 a.m.
yeah, 7 p.m. to 4 a.m. We talked about why that is, right? Number 5, between what hours does the graph stay level, where reaction times are fairly level? Andrew?
Oh gosh. 10 a.m. to 4, 8, 1.
10 a.m.
10 a.m. to 1 p.m.
Oh,
Pretty
1
much
p.m.
stay level to
Yeah.
from 10 a.m. to 7 p.m. They go up and down a little bit,
Okay.
but during that time they pretty much stay the same. They're only changing by half a second.
Yeah. I guess. Yeah.
Now, what are the answers to the questions? Was Peter's prediction accurate? Yeah, pretty much. Right. Yep. Good, Katie. Yep. What conclusions can you draw? What happens to your reaction time as you get tired?
Well, your brain is tired, so it just reacts slower.
Slows down. Correct. Yep. All right. What I want you to do is finish the worksheet, both sides. For 7 and 8, use the bar graph at the bottom. Answer those questions. And then use the graphs on PW56 to answer the rest of those questions.